All right. So now let's look at larger roots. Now let's take a look at something like this. 2 times 2 times 2 is equal to 8. So what we have is 2 times itself, and we have 3 2's. So what we're going to say is this is what we call the cube root of 8. So a cube root is when we have a number times itself, but we have 3 of the copies of that number. So we got a 2, a 2, and a 2. And so if we multiply these together, we get 8. That means the cube root of 8 is 2. Now, technically, if you wanted to say this, 2 times 2 is 4. Thus, we can say, okay, the square root of 4 is 2, but we could technically write it with a little 2 there. That would be all right, mathematically speaking. But for reasons of convention, we leave the 2 off. This is one where we don't put it there. Now, what if we have 4 2's? Well, 4 2's give you 16. So that means the 4th root of 16 is equal to 2. Do another one. 5 2's. Well, that gives you 32. So that means the 5th root of 32 is equal to 2. And so on. This continues to 6th roots, 7th roots, 8th roots. For the 8th root, you take 8 2's, multiply them together. Let's see, 8 2's, that comes out to, let's see, 256. Multiply 8 2's together, you get 256. That means the 8th root of 256 is 2. So that's this idea of higher roots. Now, so far we're taking positive roots. We don't have any minus signs. So what happens if we deal with negative numbers here? Well, what we can do, let's start with -2 times -2 times -2. Well, -2 times -2 is +4. +4 times -2 is -8. So in this case, we can take a cube root of -8, and we have same number, same number, same number, so it's a root. That comes out to -2. So what we start finding is that with cube roots, we can take the roots of negative numbers. So let's say we do this. Let's say -3 times -3 times -3. Well, -3 times -3 is +9. +9 times -3 is -27. Same number, same number, same number, and there's 3 of them. So that means the cube root of -27, well, it's this repeated number. We get a -3. So there we go. We can take the cube roots of negative numbers. So that is allowable. Now, let's take a look at something. What about the fourth root of negative numbers? Well, let's say we do this. Back up here a little bit. Let me show you this first. If you multiply these together, you get 16. Also, we saw that is also 16. So with these fourth roots, we have a positive version, but we also have a negative version. So once again, let me put my little 4 there. We've got 2 roots. Now for the -8 that we just did, we took a cube root. Well, there was only one root, -2. But once we get the fourth roots, again, like square roots, we're going to get a positive root and a negative root. This is a general thing. For even roots, or for even roots, there is a positive and negative root. So square roots or root 2, fourth roots, again, you got a positive and a negative. But for odd roots, you don't have this. So for odd roots, we're only going to get the one root. Now, there's another difference between even and odd that we want to talk about, even roots and odd roots. And it's going to be this. For even roots, we can take the even roots of positive numbers. But we've seen that we can't take the square root of negative numbers. Could you take the fourth root of negative numbers? Well, let's say we have -16. Well, we could do 2 times 2 times 2 times 2 times 2. Oh, wait, no, we got to make one of these negative. Not going to work. So we got to do something like that. But then, well, we don't really have a root anymore, because we need a negative times a positive to get a negative still. These will multiply to a positive, but that's going to be a negative. Well, we could do it like this. Now, these will multiply to a negative, and then negative times positive is negative, but we need to keep that one positive. No matter how we arrange this, we're going to get different numbers. We have a positive number that will be different from a negative number. So in this case, -16 doesn't have a fourth root. We don't have some one number, and we have, we got a total of 4 copies of it. All of them are exactly the same, and then we can multiply those together and we get -16. We always need a negative, or we always need a positive. We always need something that's different. So that means we don't have a root. So we've got the same situation here with negatives for fourth roots as we do for square roots. Now, all this means is this. If we have an even root, we have a negative number. We cannot take the even root of that negative number. We cannot take the even root of a negative number. Now we have seen we can take the odd root of a negative number. So we can do this. If you recall the cube root of -8. Well, -2 times -2 times -2. It's 3 of the same number. So the cube root of -8 is that -2, it turns out. Now we can summarize this in a chart. So can we take the even root of a positive number? Absolutely. Square root of 4, fourth root of 16, we can do that. We're good to go. We can also take the odd root of a positive number too. The cube root of 8. 2 times 2 times 2 gives you 8, so the cube root would be 3. I'm sorry, 2. Now we can take the odd root of a negative number. The cube root of -8. Well, because -2 times -2 times -2 gives you -8, the cube root of -8 is -2. But what we can't do is we can't take the even root of a negative number. That we can't do. So that's the one that we have to watch out for. We cannot take the even root of a negative number yet, but that's for future times. So let's do some more examples. So let's say we have something like this. So let's say we want to find the fourth root of 1. Well, is there some number, and we have 4 copies of it in total. If we multiply those 4 copies, do they give us 1? Well, there is. One. Thus, the fourth root of 1 is 1. Well, there you go. Now, let's take a look at let's go with the fifth root of 1. Well, since 1 times 1 times 1 times 1 times 1 equals 1, Thus, the fifth root of 1, well, that's also equal to 1. All right, we're doing things with 1. Let's pick something more adventuresome. The fifth root of 100,000. Now, admittedly, you'll have to play around with some calculator stuff here, but it turns out that if you take 5 tens and multiply them together, you'll get 100,000. And since these are all the same number, and there's 5 of them, we can take the fifth root, and that's going to be fifth root of 100,000. Well, that's going to be equal to 10. All right. Now, let's say we do this, though. Let's say the fifth root of 32. Now, thinking back to your chart, we can do odd roots of positive and negative numbers. We can do even roots of positive numbers. We just can't do even roots of negative numbers just yet. So what number times itself, and let's say we have 5 of these numbers, that will turn out to be negative 32? Turns out to be this. If you take 5 negative 2's and you multiply them all together, turns out they're equal to negative 32. So that means since each one of these is exactly the same, they're all negative, there's not a positive one in there. They're all negative, and they're all 2's, negative 2's. We can take the fifth root. So the fifth root of negative 32 is negative 2. All right. So we can do even roots of positive numbers. Do another one like that. Let's say we do the sixth root of 64. And again, you might not know this, but we're going to learn about multiples of 2 in this class. 2 times 2 times 2 times 2 times 2 times 2 is 64. So 6 2's multiplied together gives you 64. So that means the sixth root of 64, well, that's going to be 2. Finally, what if we try for the sixth root of negative 64? Well, once again, we can't take the even root of a negative number. So what we're going to get is not a real number. All right. So we want to talk about, again, these absolute values. So let's recall this. If we take the positive square root of something squared, it could be a number, it could be x. We take the positive square root of something squared, we get the absolute value of whatever that was. So for example, the positive square root of 3 squared is the absolute value of 3, or 3. Likewise, negative 3 squared, square root of that, is going to be the absolute value of negative 3, or once again, positive 3. And with this one, the way you can think about it, when you square negative 3, you get positive 9. So what's the square root of positive 9? And you'd say, well, I mean, we're dealing with negative 3, so shouldn't you get negative 3? Hold on. This, because there's no minus in front, this says we want the positive square root. So we're going to turn negative 3 into a 9, and then we want the positive square root of 9. Well, that's got to be 3. And so that's why that's working the way it is. Same thing here. We turn 3 into 9. Positive square root of 9, again, is going to be 3. It's a little subtle trick there. Now, what about cube root? Well, let's say we take the cube root of 2 cubed. Well, 2 cubed is 2 times 2 times 2, which is equal to 8. And again, with the cube root, we're going to now take the cube root of 8. Well, 3 2's multiplied together gives you 8, so that means that's going to be equal to 2. So this means the cube root of 2 cubed is equal to 2. So looks sort of like what we did with square root so far. So what happens if we make 2 negative? So cube negative 2. So we asked for the cube root now of negative 8. Now, even though there's no minus in front of this, the way we handled this was, well, okay, what are the 3 numbers that multiply to give us negative 8? And it turns out, even though there's nothing in front of this, we kind of don't have a choice here. Again, negative 2 times negative 2 times negative 2 is negative 8. So that means 3 things that are multiplied together to give you negative 8 is, well, it has to be negative 2. So when we're dealing with these odd roots, we're not going to worry about what's in front here when it comes to determining what the root is. With positive roots, we do got to think about that. But with odd roots, we don't. We're not going to worry about, if we see a negative out here, we can call it a times minus 1. And I'm going to be honest with you on something here. Anytime you have a minus here, even when we're dealing with an even root, and you saw this earlier, you can always treat it as a times minus 1. In some ways, it's easier to do that and treat the square root or the 4th root as a positive root times minus 1. I'll do an example after this. So this is what we end up getting at the end. Cube root of negative 8 is negative 2. So what we find, well, it just pops out like before when we had a positive 2. So in general, for odd roots, this is what we're going to get. Whatever's on the inside just gets kicked out as your answer for odd roots. So whether it's -2 or positive, it's just going to pass on through and you just extract it and that's your answer. Now, what I wanted to get about with the even roots, I was talking about those minus signs. What you can do, like let's say we have minus, let's say 4th root of 16, we can try to think of a negative number, and then you take 4 copies of it in total, multiply those together, and you get positive 16. But what you could do is treat this as -1 times the positive root of 16, and knowing that 2 times 2 times 2 times 2 gives you 16. -1 times 2, or you'll still get that -2. So you can treat this as looking for the negative root, or you can kind of peel off this -1 with multiplication, and then look for the positive root, multiply it by -1. You could do it that way too. Anyway, whichever makes sense. But for odd roots, don't worry about that stuff. There's going to be one root. While with even roots, at least when we're dealing with real numbers, you're going to be dealing with 2 roots. So like the 4th root of 16 could be -2. It could also be +2. There are 2 4th roots in there. But as for other roots, more than 2, that's another conversation. But for real roots, go with 2. So let's take a look at even them. So let's say we take the 4th root of 2 to the 4th. And to be honest, I'm going to use that convention of positive and negative root again. Well, this will be the 4th root of 16, and we know that's going to be 2. And if we have this, well, again, this will be the 4th root of 16, but again, positive root. There's no minus in front. So what's the positive root of 16? Well, it's still going to be 2. So when you have an even root, and we have the even root in the even exponent, it takes an absolute value. You'll get the positive version back. So what we're going to get this becomes the absolute value of A. So let's do some examples. Get some practice on this so it makes more sense. So again, with the even roots, I'm making it a deal if there's a minus in front of here or not. Not for the odd roots. With the odd roots, I just treat that as an odd root times -1 if there was a minus in front of it. If there's no minus in front of it, don't worry about anything. But with the minus in front here, sort of using the convention of the text, you do want to kind of think about that. So anyway. So let's take a look here. So let's do some examples. Cube root of x cubed. Odd root, odd exponent, thing just passes right through. We're done. But if we have this, we're going to take the absolute value. And that's going to be our answer. Even root, even exponent. Now, if we have something like this, cube root of -5 cubed passes right on through. odd root, odd exponent. But if we take the 8th root of -5 to the 8th exponent, or 8th power, this will be the absolute value of -5, or 5. So it doesn't quite pass on through, only as a positive number. And so that means if we have something like this, even root, even exponent, we're going to get the absolute value of what's on the inside. But if we have this, -8x cubed, well, we can make a note that -8x cubed is -2x times -2x times -2x, or the cube root of -2x cubed. And since this is an odd root, it's going to pass on through -2x. And let me do one more here. Another odd root one. Now we might recall that -2 to the 5th is -32. So we can rewrite this as the 5th root of -2 to the 5th, x minus 1 to the 5th. And we could think of this as like having distributed this exponent, and we can rewrite it. Like so. And so 5th root, 5th power, and that's going to mean no absolute value. Let's get -2 x minus 1. All right. So that's it for section 7.1. If you have any questions, let me know, and then we'll move on to 7.2 shortly.